In this video, we'll generate the dataset of the arcsine function, the inverse hyperbolic sine function, and the Taylor-Maclaurin series sum of both. We begin with the arcsine function, which is our formula, arcsine of the x values. And here you have the polynomial and the trend line of the arcsine function. We continue with the inverse hyperbolic sine, arcsine, that is equal to our formula, inverse hyperbolic sine of the x values. And here we have the trend line of the inverse hyperbolic sine and the trend line equation as well, also the polynomial. We generate the Taylor-Maclaurin series sum expansion to approximate both. So, which is the summation of a times x to the power 2n plus 1, where a, the coefficient, is equal to k to the power n times factorial 2n all over 2 to the power n times n factorial raised to the power 2 times 2n plus 1. And the value of n is from 0 to infinity. In this case, we can go as far as we can try reach infinity. 16 is good enough. And the value of k will be negative 1 or 1. So data validation. List of items, negative 1 or 1. Now we continue with we start with negative 1. We start with the series sum. So this is now array formula, series sum of the x values raised to the power 2n plus 1. So starting from 1, incremented by 2n, where 2n is 0, 2, 4, 6, 8. So the interval is 2. And the coefficient will be this range. So we continue with the coefficient. This is equal to, starting with the numerator, that is k raised to the power n. We're going to use this very often, so we'll copy this. Times factorial 2 times n. That is 2 times n. Now we have completed the numerator. We'll continue with the denominator, which has two parts, this part and 2n plus 1, the second part. So divided by the first part, that is 2 to the power n times factorial of n. And this whole expression is squared times the quantity 2n plus 1, 2 times n plus 1. Then enter. So at k is negative 1, the red line, the red data set approximates the inverse hyperbolic sine. That is, the expansion approximates the the inverse hyperbolic sign at k equals 1, positive 1, then the Taylor series expansion approximates the arc sign. We'll calculate the regression coefficients using LINEST. So this will be, we start with the matrix, it's array formula, the LINEST matrix of the x values raised to the power 0 to 6 because our polynomial is to the 6th degree. Then enter. Now we can enter LINEST. This is equal to LINEST. This will be your data y and data x. These are the polynomial regression coefficients of the arc sign. Now the expansion, which is equal to r from LINEST data y and data x. These are the polynomial regression coefficients of the Taylor series expansion. And finally, LINEST data y and data x. These are the polynomial regression coefficients of the inverse hyperbolic sign. Now let's compare. So at k equals -1, so the red trend line is on the green dataset. The expansion approximates the inverse hyperbolic sign, and the regression coefficient of the expansion also approximates the regression coefficients of the inverse hyperbolic sign. At k equals 1, the red trend line is on the blue dataset. So the Taylor series expansion approximates the arc sign, and the trend line polynomial coefficients also approximates the arc sign coefficients. This completes the use of the Taylor series sum, Taylor Maclaurin series sum, and LINEST polynomial regression to generate the polynomials of arc sign and inverse hyperbolic sign.